So I think with that intro, and I'd like to get into the next, the second segment of this interesting webinar, which is basically trying to, present the findings from very empirical studies on farm ponds. Try to give us a big picture. So a big picture view of farm ponds in Maharashtra and its impact. Move to the second short presentation, that is by Dr. Taufique Warsi and Vijay Solanky. And in fact, they're going to touch upon the hydrogeological findings and impacts in these 6 study villages. Dr. Taufique has a PhD in geophysics, and Vijay has a background in Geo-informatics, and both are researchers with WOTR. So it's over to Taufique and Vijay.
Yeah, thank you, Joy sir. Good afternoon, everyone. Myself, Taufique Warsi. Along with me is Vijay Solanky. Till now, we have seen the socio-economic aspect of farm ponds. Now we'll have a closer look of hydrogeological findings in the farm pond scenarios. So in order to fill the farm ponds, farmers extract huge quantum of water from the extracted structure in terms of bore wells and dug wells. As a result, a local cone of depression form which influences the surrounding wells under zone of influence. So to demarcate the zone of influence, several wells were selected around the pumping well, and subsequently in situ parameters in terms of electrical conductivity, pH, TDS, salinity, and temperature were analyzed. And if you see the idea behind measuring these parameters was to understand the dilution of solids away from the pumping well and eventually demarcate the zone where the dilution effect ends. A breakthrough curve was generated also using in situ parameters with respect to the distance of observation well from the pumping well, which finally reveals the impact around the pumping well. Now coming to the next slide, we have taken the Google image to make it more lucid. This is the case study of one farm pond where, like you can see, the farm pond, all the farm pond is located near the foothill, and an elevation profile was also generated to understand the topographical difference across the wells and identifying the location of farm pond. In this case scenario, the farm pond owner is lifting water from dug well, which is situated around a 254-meter downslope of the farm pond, which you can see in the elevation profile. As a result of pumping of source well, the influence can be seen on the surrounding 3 wells, which is falling in the zone, and readily it goes like 130 meters from the source well. Coming to the table, this is the statistical data acquired from the field. As we can see, the table concludes the total number of farm pond, non-farm pond household, and the wells which are coming within the zone of influence. As we can see, a total of 41 farm pond owners are affecting 68 non-farm pond households who are having 84 water sources within the zone of influence. It has been observed that the water availability of 50 wells have been reduced by 3 months, whereas 23 wells are showing the reduction of 1 month. Coming to the next. Yeah. Now, talking about the frequency in the first table, it optimizes the frequency of farm pond filling on annual basis, where the frequency varies from 1 to 30 times depending upon the size of farm ponds. As per the frequency of filling total volume of water, it has been calculated on annual basis, and it was found that like 26.7 lakh cubic meter water is being lifted by 61 households, and this will be equal to like 2,67,000 tankers. Yeah. So in this section, we have used like artificial recharge zone map generated by GSDA, and all the farm ponds under study is superimposed on the map. So like the map is mainly categorized into 3 sections, where you can see the blue color indicate the high priority recharge zone, yellow showing moderate priority recharge zone, and orange shows limited scope. So in the study village 2, out of 34 farm ponds, there are 16 farm ponds like which are falling on a high priority recharge zone, and simultaneously there are 26 dug wells and bore wells which are tapping water to fill the farm pond from the same zone. So you can see huge quantum of water is being like pumped from the high priority recharge zone, which makes the situation more worse. It has been observed that 13.54 hectare area is covered by impervious land farm ponds falling in a high and moderate priority recharge zones. Since the farm pond are lined with impervious layers, so it blocks the water from infiltration, which in turn hamper the recharge rate in the respective zones. Now over to Vijay.
Thank you, Taufique. Good afternoon, everyone. I am Vijay Solanky. So I will be presenting the remaining slides of this presentation. So as you have already seen the distribution of farm pond in our 6 study villages. Go to the next slide. Yes. So as you all have seen the distribution of farm pond in the study villages, there are the yellow color villages which you see on the right hand side map. These are our 6 study villages, and the other villages are the neighboring villages. As GSDA has declared the Sangamner block of Ahmednagar district as overexploited, so we thought to investigate the situation of farm pond in the neighboring geographies. So we created a 9 by 9 kilometer grid for this purpose. And in this grid, 9 by 9 kilometer grid, 34 villages were falling, which covers around 41,610 hectare of area. So you can see in these 34 villages, there are around 1,453 farm ponds. And especially in few villages, the density of farm ponds is very huge, like in this north central village, if you can see on the top, and even in the right hand side village, the density is very huge of this farm pond. We have also analyzed the temporal changes in the cropped and cultivated area with respect to the farm ponds. Wherever the farm ponds are constructed, then we analyzed what are the changes in the cultivated area using satellite images. So for this purpose, we have used Sentinel satellite images of 4 years, 2015, 16, 18, and 21. For all 4 years, we have considered only the Rabi season, because farm ponds are supposed to provide the irrigation in Rabi season more. So out of these 4 years, 2 years are drought year, 2015 and 2018, and 2 years, 2016 and 21 are the normal rainfall year. So these 2 years, in 2015 and 18, you see in this map, the yellow circle, the yellow pins are the locations of the farm pond, and these red patches in this map are representing the agricultural area or the cropped area. So even in the drought year, the cropped area is very clearly visible, which means the farmers are able to take the crops in the Rabi season in a drought year, after a drought year. So, but this is one aspect of looking at it. But when we see it from where they are filling it, as we have seen in the previous slide, so these farm ponds are being filled from the groundwater, even in the drought year. So, and you know, in the drought year, there are more evaporation losses also. So this is one aspect which we have investigated. Now, to put it all together, the study of these 6 villages. Next. Yeah, to put it all together, the study of these 6 villages, we have analyzed the impacts on various verticals. So first major impact is on the recharge of the groundwater. So in these 6 study villages, there are 178 impervious farm ponds, which occupy 13.54 hectare of area under the high and moderate priority recharge zones. And within this recharge zone area only, there are additional borewell and dug wells also, which are extracting the water. So it is not only that the farm ponds lined with the plastic or the impervious line are blocking the recharge in this very high and moderate priority recharge zone. It is also tapping and extracting the water through the borewells and dug wells. The second impact is on the evaporation loss, which is we have calculated to approximately 6.67 lakh meter cube of these 68 farm pond. And this, if we convert, which comes to a significant number of 66.7 thousand tankers of water of 10,000 liter capacity each. Under the social and economic losses, there are 68 farm pond which belongs to 61 household, which lift approximately 26.7 lakh cubic meter of groundwater annually, and this is a huge amount. The sources, which are mainly the borewell of 41 farm pond owner, these are negatively impacting the borewell and dug well of 68 non-farm pond owner, as well as their wells are located in the zone of influence of the source well. And unknown number of households having the borewell and dug well are also affected, which are situated in the downstream, which here a common aquifer. So with this, I would like to end my presentation. Yeah, thank you.